So this is Chapter 6, Security Through Network Devices. Some of the standard network devices are switches. A network switch is a device that connects network segments. A switch has a degree of intelligence, at least a managed switch for sure. Operating at the data link layer, which is layer 2, a switch can learn which device is connected to each of its ports and forward only frames intended for that specific device or frames sent to all devices. Those are unicast or broadcast frames. A switch learns by examining the media access control address of frames that it receives. That's the MAC address. And then associates that port with the MAC address of the device connected on that port. And then it switches the traffic destined for that MAC address. Routers. Routers operate at network layer, which is layer 3. A router is a network device that can forward packets across computer networks. When a router receives an incoming packet, it reads the destination IP address, and then using information in its routing table, it sends the packet to the next network towards its destination. The router can be configured to filter out specific types of network traffic. Load balancers are another standard device. Load balancing is a technology that can help to evenly distribute work access across a network. Because load balancers are generally located between routers and servers, they can detect and stop attacks directed at servers or applications. A load balancer can be used to detect and prevent denial of service and protocol attacks that could cripple a single server. And then we have some security hardware that's specific for security. Those are firewalls. Hardware firewalls are usually located outside the network security perimeter as the first line of defense. A firewall can take several actions when it receives a packet, such as allow, block, or prompt, which means it asks. There are two methods for determining firewall actions. There are rules-based and settings-based. A rule-based firewall uses a set of individual instructions to control the actions. These rules are a single line of textual information containing such information as network addresses and port numbers of services that are allowed or blocked. Settings-based firewalls operate at a higher level. Instead of creating hundreds of specific rules that have precise and very granular instructions, the settings-based firewall allows the administrator to create sets of related parameters that together define an aspect of the device's operation. Packets can then be filtered by a firewall in one of two ways. Stateless packet filtering looks at the incoming packet and permits or denies it based on the conditions that have been set by the administrator. And the stateful packet filtering keeps a record of the state of a connection between an internal computer and an external device, and then makes decisions based on the connection as well. Proxies. Several different types of proxies are used in computer networking. These devices act as substitutes on behalf of the primary device. A proxy server is a computer or an application program that intercepts user requests from the internal secure network and then processes that request on behalf of the user. Proxy servers have several advantages. Increased speed. Because proxy servers can cache material, a request can be served from the cache instead of retrieving the web page through the internet. Has reduced cost. Proxy server can reduce the amount of bandwidth usage because of the cache. It has improved management. A proxy server can block web pages specifically or entire websites. And it has stronger security because acting as the intermediary, a proxy server can protect clients from malware by intercepting it before it reaches the client. Reverse proxy does not serve clients but instead routes incoming requests to the correct server. There are hardware spam filters. Due to the high volume of spam, most organizations use some kind of enterprise-wide spam filter to block spam before it ever reaches any host. Email systems use two TCP/IP protocols to send and receive messages. They are Simple Mail Transfer Protocol, or SMTP, that handles outgoing mail, while the Post Office Protocol, or POP, usually called POP3, is responsible for incoming mail. Two options are available for installing the corporate spam filter. Install the spam filter with the SMTP server. This is the simplest and most effective approach to installing a spam filter. The spam filter and SMTP server can run together on the same computer or on separate computers. The filter, instead of the SMTP server, is configured to listen on port 25 for all incoming mail messages and then passes the non-spam email to the SMTP server that is listening on another port. This configuration prevents the SMTP server from actually notifying the spammer that it is unable to deliver the message. The messages just disappear. You can also, as a second way, install the spam filter on the POP3 server. Although the spam filter can be installed on the POP3 server, this would mean that all the spam must first pass through the SMTP server and be delivered to the user's mailbox. Another method to filter spam is to contract a third party that filters out spam and then forwards the email that's not spam to the organization. There are also virtual private network concentrators. A virtual private network, or VPN, uses an unsecured public network such as the internet, as if it were indeed a secure private network. It does this by encrypting all data that is transmitted between the remote device and the network. And a VPN concentrator is what does that. These can be built into firewalls. Internet content filters can be a hardware device. Internet content filters can monitor internet traffic, block access to pre-selected websites and files. Web security gateways. A web security gateway can block malicious content in a real time as it appears without first knowing the URL of a dangerous site. Web security gateways can block the following: ActiveX objects, adware, spyware, cookies, instant messengers, peer-to-peer file sharing, script exploits, and TCP/IP malicious code attacks. There are intrusion detection hardware and prevention. An intrusion detection system, or IDS, is a device designed to be active security. It can detect an attack as it occurs. IDS systems can use different methodologies. One is anomaly-based monitoring. That is designed for detecting statistical anomalies. First, a baseline of normal activities is compiled, and then whenever a significant deviation from this baseline happens, an alarm is raised. A second method for auditing usage is to examine network traffic, activity, transactions, or behavior, and look for patterns. Much like antivirus scanning, this is signature-based monitoring because it compares activities against a predefined signature. And then there is behavior-based monitoring. This attempts to overcome the limitations of both anomaly-based and signature-based monitoring by being more adaptive and proactive instead of reactive. Instead of using statistics or signatures as the standard, behavior-based monitoring uses the normal processes and actions as the standard. Behavior-based monitoring continuously analyzes the behavior of processes and programs on a system and alerts the user if it detects any abnormal actions, at which point the user can decide whether to allow or block the activity. The final method takes a completely different approach and is founded on experience-based techniques known as heuristic monitoring. It attempts to answer the question, will this do something harmful if it's allowed? IDS heuristic monitoring uses an algorithm to determine if a threat exists. There are two basic types of IDS, intrusion detection systems. There are host intrusion detection systems and network intrusion detection systems. A host intrusion detection system, or HIDS, is a software-based application that runs on a local host computer that can detect an attack as it occurs. HIDS typically monitor the following desktop functions: system calls, file system access, system registry settings, and host input-output. HIDS has a few disadvantages. It cannot monitor network traffic. If the traffic does not reach that local host, it can't monitor it. All log data is generally stored locally on that computer, and it tends to be resource intensive. It can slow down the computer. A network intrusion detection system, or NIDS, watches for attacks on the entire network. As network traffic moves through the network, NIDS sensors, usually installed on network devices such as firewalls and routers, gather information and report back to the central device. Once an attack is detected, NIDS can do different things. A passive NIDS will simply sound an alarm and log the event. These alarms may include sending an email, a page, a cell phone message to the administrator, or even playing an audio file, Star Trek, incoming missile, whatever. An active NIDS will both sound an alarm and take action. The actions may include configuring the firewall to filter out the IP address of the intruder, launching a separate program to handle the event, or terminating the session by forging a TCP FIN packet to force the connection to terminate. There is also a network intrusion prevention system, or NIPS. It's similar to NIDS in that it monitors network traffic to immediately react to block malicious attacks. A NIPS, on the other hand, would be located inline on the firewall itself. This can allow the NIPS to more quickly take action to block an attack. And obviously, someone thought, hey, let's put all those devices in one appliance. That brings us to all-in-one network security appliances. An alternative to multiple dedicated devices would consist of integrated devices, sometimes called all-in-one network security. These multi-purpose security appliances can provide an array of security functions such as anti-spam, anti-phishing, antivirus, anti-spyware, bandwidth optimization, content filtering, encryption, firewall, instant messaging control, intrusion protection, and web filtering. Which brings us to network security through different network technologies. The first we'll talk about is network address translation, or NAT. NAT replaces a private IP address with a public IP address. As a packet leaves the network, NAT removes the private IP address from the sender's packet, replaces it with an alias IP public address, such that the entire LAN might just have one internet routable address. The NAT software maintains a table of the private IP addresses and alias public IP addresses. And when a packet is returned to the NAT, the process is reversed so that the private address replaces the public and it can go to the proper machine. NAT has two advantages. It masks the IP addresses of internal devices, and it allows multiple devices to share a smaller number of public IP addresses. A second technology is network access control, or NAC. NAC basically examines the current state of a computer or system or device before it's allowed to connect to the network. Any device that does not meet a specified minimum set of criteria, such as having the most current antivirus signature or the software firewall properly installed, is only allowed to connect to a quarantine network where the security deficiencies are then corrected. You can also have security through design elements. And one of the first design elements is a demilitarized zone, or DMZ. In order to allow untrusted outside users to access resources such as web servers, most networks employ a DMZ. The DMZ functions as a separate network that rests outside the secure network perimeter. Untrusted outside users can then access the DMZ but cannot access the secure network. We also use subnetting for security. Instead of just having networks and hosts with subnetting, networks can essentially be divided into three parts: network, subnet, and host. Each network can contain several subnets, and each subnet connected through a different router can contain multiple hosts. Subnets can also improve network security. Network administrators can utilize network security tools to make it easier to regulate who has access in and out of a particular subnet. That brings us to virtual LANs, or VLANs. It is possible to segment a network by separating devices into logical groups. This is known as creating a virtual local area network. A VLAN allows scattered users to be logically grouped together even though they may be attached to different switches. This can reduce network traffic and provide a degree of security similar to subnetting. VLANs can be isolated so that sensitive data is transported only to members of that VLAN. and remote access. Remote access refers to any combination of hardware and software that enables remote users to access a local internal network. Remote access provides remote users with the same access and functionality as local users through a VPN or dial-up connection, hopefully a VPN. And remember, keep calm and document everything.